Okay, welcome everyone. This is the working group device management meeting for June 10th, 2025. We've got a few things on the agenda, so let me just go ahead and share my screen real quick. We can start going through them. Let's see. Okay, can everyone see this?
Yeah, looks good.
Okay, let's go ahead and start with Patrick. You said you're in your car. Are you able to talk through your first one here?
I can try, and you can tell me if it's too noisy. So
Okay.
first bullet item is just a reminder for all the reviewers, tech leads, interested parties, stakeholders, CAP offers, and whatever, that we are approaching CAP freeze. It will be next Friday. And I forgot to list the production readiness deadline, which is actually a bit earlier. What that means is that by production readiness deadline, which I think is tomorrow or 2 days later, something like that, all the CAPs should have a PR pending where everything has been filled in, and the PRR team needs that to prepare the reviews that will happen throughout the next week. We have lots of CAPs this cycle. Again, we discussed a little bit which of them are important, and I think I tried to capture that. It's partly based on the slide that John shared. So at the very top is clearly the GA promotion of core DRA with structured parameters.
I can jump here, actually. I think you said this is a prioritized list. Yeah.
Yes, I reordered it basically, and that's a bit up for debate. Of course, it's my personal view, and to some extent that gets reflected here. If you scroll to the right, in review, we do have all the CAP PRs. It's to the right. At the right. I can only see. Yeah, it's there. I just had to tilt my screen. So at the top, we do have the priority, the structured parameters. I tried to rationalize the order a little bit. So that's the core part. That's clearly the crucial part. Then some other important part in terms of impact is the mapping of extended resource API to DRA, but I think that's actually in a fairly good shape. I think it's almost done. We just need to have some last few comments addressed or consensus, and then we can lift the whole. It's merged. What follows for me conceptually or in terms of priority is something that has been discussed for a while. Some of these have been proposed almost one cycle back. Consumable capacity has had a long lead time getting ready for being alpha in 134, and it would just be fair to give those people who have put in a lot of time a chance to get it to alpha this cycle. Also, the CAPs should be more or less ready because we also did a lot of reviews on them already. So I feel that consumable capacity and binding conditions, they both fall into this bucket, that they are ready for alpha in 134. We just need to get the last approvals that are currently still missing. SIG scheduling already, they indicated that they are time limited. So I on Slack, I pointed out these two PRs also just to get the attention. Then lower priority are all the new things. Oh, well, next into priority is beta promotions. So basically features that we already had as alpha. We now have.
Patrick, sorry. Are you suggesting this one should actually be higher than below this one?
No, extended resources is merged. The consumable capacity for me is at the right place. So this should. Yeah.
So what you're saying, this should actually be moved over.
This got merged this afternoon while I wasn't looking.
Got it.
Yeah. Device bindings. So these two are new alpha features or will be new alpha features, but they have been discussed for a long time. Let's just get them across the finish line for CAP merging before the CAP freeze. And then we do have a few updates where people are proposing to promote to beta. I think that number is prioritized lists or prioritized alternatives.
Yep.
I can't tell from cap number.
Yep.
So
Anyways, I just looked at it. It's the prioritized
Yeah.
alternatives. Yeah.
yeah. So that just needs to be reviewed. Same with that one. I don't know which.
This is the pod. This is pod resources API.
Yeah.
Mhm.
Okay. Yeah. I think when we can promote, when we feel that we are ready to promote a beta to beta, we should, but it's lower priority. I don't think any of these are absolutely crucial. But that's just my take on this. I think it makes sense to just consider them. And then further down come a lot of new PRs, new caps that actually are in some cases as new as yesterday. And this is clearly at risk. It's fairly late to start an entire new feature and kick off a review and discussion. But we can try. I just wouldn't risk the other ones for something that's entirely new. That's basically my take on it. I hope it makes sense. Otherwise, we can reorder or discuss further.
Yeah, it makes
And it
sense
also all
for
depends.
everyone else on
Yeah.
for everyone else on the call. Does anyone see? Can anyone think of something that's not on this list that they think should be? Or does this actually capture everything? That's the only question I'd have.
I think the only thing worth calling out is that Signode is tracking a different board for reliability and operational readiness for 134. So I think this is primarily features and potentially bug fixes. But in terms of being able to predict GA readiness, I think we want that board as well. Does that sound right to you, Patrick?
Sorry, the VGA readiness board. Yeah, that's another board in that same project board. I've tracked all the things that we.
Yeah, I was just gonna say we're not really at the stage of the 134 release cycle where we need to worry about it too much. Everyone's just focused on caps, but that's just a call out that going forward, we probably want to review both boards for identifying.
Well, in terms of actual implementation work, that then follows from the GA blockers. Those have priority in terms of getting the implementation reviewed, and we certainly need to make at some point a judgment call whether we have done all the things that we wanted to do for GA before we actually promote it. But that follows later. So now it's just about the cap being merged to plan on to start off the work towards GA. I hope that I'm not sure if that answered the question.
You're saying that board's an extension of this. It's all the things that we actually have to do. Assuming this cap gets merged, that's what has to get actually done.
It's another tab at the top. It's called Core GA. And it's both. Core GA is the things that we need to do for the structured parameters cap to go GA. It includes most of the reliability things, but not everything. So sometimes it's the same thing, sometimes it's not. So we have some reliability things where we just said, well, no, this is not a GA blocker. So the reliability board has other things that are below the GA threshold. And that's another tab. If you go to the reliability tab, that has at the top the GA things, and at the bottom all the rest.
Got it. So in theory, if everything from here made it to done, and everything in the GA side, and then everything from here made it to done, then we're ready for GA.
Then we should be ready. Yes, fingers crossed. But it looks doable. I mean, I've started a lot of work on those GA criteria or blockers already, and I'm fairly confident that we can do it.
Okay, good. Let me go back here and here. Okay, Patrick, is there anything else you had from your agenda item then, or was it just going through that?
No, that was pretty much it.
Okay. Any questions from anyone on that, or shall we move to the next item? Okay, CleHub, are you on the call today?
Yes, I'm here.
Christian. Okay. I
yeah,
didn't realize
yeah.
I didn't recognize the name. How's it going?
Okay. Hello,
Yeah.
long time no see. So,
Yeah, same.
so basically I have to say that I'm a little bit unprepared. So because of that, I was thinking that I should ask Rohit that if she is having basically a more coherent presentation, then maybe we should do that first, because I wouldn't like to steal the time if she has put in some serious effort into doing a presentation, and then I could use the remaining bits of this meeting for my stuff. But it's up to her how she would like to do it. So because my might be short, long, I don't know, because it's just I saw that it's maybe a discussion. So I just wanted to bring to folks' attention to that since there is this DRA CPU allocation feasibility study. So we threw together a practical prototype with a few simple goals, and these were basically to allow practical experimentation with something using some existing code base and some really brutal hacking, throw something together quickly that people could pull in with a few commands and try in practice. And I was also, of course, interested in what kind of problems we are running into if we try to co-host in a way native CPU allocation with a DRA front, and then what kind of problems we are running into, and also do some experimentation with some kind of abstraction, how we could abstract basically CPUs as DRA devices, and then what kind of problems we are running into when we try to allocate via DRA and attribute selection things. So I have something which I think is usable already to some extent. So if people are interested, then I can share basically, and then those who work in this area and are interested in trying something in practice can try it out for themselves, and then then maybe it will be helpful in this feasibility study, because that was the whole idea with this.
I'm definitely interested in trying it out.
Okay.
Same here.
Okay. So what I can do is that I can. So would you like to see something about it? Because I can show, for instance, what kind of things I have been prototyping with on the abstraction front, because I think that's the most interesting thing. So if you are interested, I can show you some small things, but I think it's really up to the next presenter, that if she has a coherent presentation, I think it's better to do that first, to be fair.
You want to jump to that then quickly, and then we can come back after?
That would be
after it's
fine with
done?
me. Yeah, I think
Okay.
it would be fair.
Okay, let's do that then.
Good. Let me share my screen. Or, yeah,
You should,
thank you.
I'll stop mine.
Sorry, I need to allow Zoom access to screen share. I might have to leave the call in order to do that, so sorry about that.
Yep.
While she's coming back, I have a quick question. I wanted to ask, Patrick's had a comment on my CAP PR, asking about gathering feedback from the consumers of DRA feature. How is that usually done? Is there a criteria for doing that?
It's always been problematic to get proper feedback. As a feature owner, you probably implemented a feature for someone, and you know that it's being used, or you have some evidence that someone has tried it out. We face the same challenge with every single feature. There's no good no good one answer. Sometimes people have done polls or queries or just open discussion threads on Slack. Anything is better than nothing. But if we don't have any feedback at all, and even the CAP author doesn't know whether the feature that they've implemented is in use, that pretty much indicates that we perhaps shouldn't promote it.
So does it count? We have the MR for integrating this updated API in NVIDIA DCGM exporter. If I
think that's good. Some kind of demonstration that this feature is being used, that someone has tried it out, that there's perhaps some CI running, testing it, anything like that that shows that this feature is stable and is being useful, that I think counts. And it doesn't even need to be answered in the CAP document itself. I think it's enough to, I don't know, have a Slack thread where you summarize this. I don't think we have a formal process or anything.
Okay, got it. Thank you.
To that extent, all of these GA or beta criteria, they are a bit subjective and open for debate, which is a good thing and a bad thing. It's not formalized, but it gives us some leeway to be flexible.
Jack, you have your hand up.
Yeah, I just wanted to respond to that question. One approach that can help to gather feedback is to search the issue history for the project, because there you're going to find people who might be describing something that your feature will actually help them solve, and so they'll be incentivized to weigh in. So if you can find issues that are described in a way that suggests that your feature will help them in the future, then you can sort of pose the question, are we proposing to do things in a way that would be suitable to address your pain, kind of thing.
Yeah.
And I think
yeah.
I was going to say, Swati, in this specific case, if we didn't consume this API, this is for about the Pod Resources API exposing information about DRA devices. If we didn't consume this in our DCGM exporter, when you allocate GPU resources using DRA, you would get no metrics about them. And that is clearly a bad thing. And so I think even just demonstrating that by adding this feature, we now get metrics from the DRA resources is probably enough for this one.
Sure. Yeah, I'll explain all of that. I was not aware if there is any proper process to follow here. But yeah, these are good points. Looking at the GitHub issues and then also showing what we are doing with DCGM exporter. Okay, thank you all.
Great.
I'm back.
You're back.
Yeah.
Great.
Cool.
Okay. Yeah. The floor is yours then.
Okay. Thanks. Okay. So I just wanted to do a quick demo of KEP 5254, which adds in cell expressions as device constraints. Let me just send that KEP over. I'll send that link over later. But this was originally slated in the DRA structured parameters KEP. So this is just implementing that feature. So currently DRA supports specifying a match attribute constraint, which evaluates a device against some attribute. What this cell expression does is it'll evaluate relationships of devices across a whole device set. So I kind of just wanted to show what the user experience for that looks like. So here I'm just using the DRA example driver and the attributes surfaced from that. So this is just the DRA example driver. And I've created a YAML file that basically creates the resource clean template. Yeah, so this is the YAML file. We're creating a resource clean template here. So the user experience for that is the same. The addition here is that you see this new cell expression constraint field. And what this is doing specifically is it's looking for 4 connected devices. So it's basically taking the index attribute and it's getting the max of all the devices in the device set. It's getting the min of all the devices in the device set, and it's making sure that it's one less than the allocation count that we've specified here. So in this case, it should return something like device 1, device 2, device 3, device 4, or any sliding window of contiguous devices. And the rest of the user experience will stay the same. You can see that in the pod spec, we referenced this resource claim template. So that's the same that was defined in the structured parameters cap as well. So this is the proposed API structure. But I'm gonna be testing with an older version of the API just because I haven't updated the code yet. But I've already updated the scheduler image and the API server image with these additions. So this is what I'm going to be testing with. You can see it's pretty similar. The cell expression is the same. It's just that this has the API format match expression instead of the cell expression that you saw earlier. And just going to create that. And what that should do is it should create a resource claim with 4 contiguous devices allocated to it. So if I just get the resource claim that was created, use this one. YAML for that. And we can see that in the allocation status, we get device 0, 1, 2, and 3. So this is just a quick demo of the contiguous device allocation. Obviously, this cell expression could be fit for many other use cases. I talk about that more in the KEP that I have. So I'll send that KEP over, but if you have any feedback, comments, concerns, let me know in the KEP and we can figure that out. Yeah, thank you. That's all I had.
All right, great. Thank you. I just have one question real quick. I don't know if others do, you can raise your hands, but what are the different methods you can call within the match expression? Like I saw devices.map and I saw just some standard like equals and stuff. What else can you do in them?
Yeah, so it's currently what version of cell we're using right now in Kubernetes. So anything that's supported in the current cell version. So map is supported, filter is supported. Any of your basic arithmetic operations are also supported. I believe sorting might also be supported. But yeah, it's whatever cell defines as supported in the version of cell in Kubernetes. Yeah.
And what's the context that we get? Just the devices that are under consideration in the same way we
Exactly.
did for the cell expression for what we're selecting. It's the same. Okay.
Exactly. Yeah.
Okay, good. Yeah. Okay, cool. Yeah, no, this is great. This is something we've wanted to have from the beginning and we simplified it for just doing attributes. And now this is, because I assume you can do everything that we currently do with the attributes. This is just much more expressive. And then
Exactly.
you get to
Yeah.
define the set of functions you want to apply across it. Great. Okay, thanks. Gaurav, you have your hand up?
Hey, yes. So I have previously been giving this some thought, and one question that I had was regarding how expressive we want this new constraints with cell to be. And the intent of my question is that I think the current implementation where we only allow matching things, I think in terms of implementation, that is relatively easier in the sense that I think it has a bounded time complexity where I think you can figure out which devices are matching with each other through maybe something like big O and complexity. But the moment you start allowing the API to express more things and you say, I want this ordering, I want to enforce this kind of ordering, like how does one figure out that all these devices are in this particular order? Like you have to go through each of the pairings or something like that. Have we given this some thought and tried to limit how expressive you would like to be?
Yeah, so for the selectors, at least the cell expression, there's currently a cap in place. so the cell expression doesn't get too crazy. So we basically can just implement that same cap on this new cell expression constraint. So we limit users and prevent them from throwing any crazy random expressions.
Which cap are we talking about, Ruhi?
Yeah, it's I forget the name, but there's a constant defined currently that was introduced in the structured parameters cap. And that cap is for the valuation cost. So we would basically just introduce that same thing. Yeah.
So there is a cost limit that is enforced by the cell runtime, but it's fairly liberal. So we still have the chance or the risk that the cell expression can become costly, and we don't really have any good way of doing any optimizations. And perhaps that's the bigger question. The cell expression is opaque. It's entirely opaque. It basically needs to be evaluated for a set of devices, and it returns true or false. There's no way to anticipate whether adding or removing one device will fix the constraint. So the scheduler will have to do brute force search of all the potential solutions and check them with cell. That part is a risk for the cap, because we currently have seen problems with core structured parameters where there is no solution, and the scheduler just keeps searching for it for a long time because it gets very close, but like being able to allocate 7 out of 8 devices and then tries other combinations, and eventually it gives up. But this can take a long time because it's combinatorial explosion basically. And this cell match expression goes in that step because, in contrast to the match attributes, we can't prune the search tree. We basically really have to come up with a full solution of devices, try the cell expression, and then discard the result and just brute force try something else.
Exactly. Yes, I do.
Yeah. What we are adding for GA of structured parameters is a timeout. But that's really just a stopgap solution that basically says, okay, well, we've been trying to find a solution for 10 seconds. We haven't found it. We have to give up on this node because we can't compute, or we can't try to find a solution forever. We have to at some point make a decision, and with that timeout and the scheduler plugin, the decision will be to not use the node. But yeah, this is indeed a risk for this proposal because we can't optimize. We basically have to do the brute force, and it will cause situations that were valid before, or solutions that were valid before, to not be considered and lengthen the search process.
Gotcha. As long as I think we are considering that sounds good to me. Just wanted to call it out. I saw this as a potential discussion point.
Yeah, it is. And I don't know whether we have captured it in the cap at the moment. That certainly would be good feedback for the cap itself.
Yes.
Yeah. Okay.
We call out this risk. Yeah.
Good. Yeah.
All right. Thanks.
All right. Any other questions on that? Otherwise, we can jump back to Christian and the CPU.
I have an extension to this demo, Kevin.
Okay.
I just wanted to, so as you have seen the cell expression, it can get quite complex. So have we ever explored an idea of saying, I am connected to these many set of devices, and such that like a adjacency matrix where each one could express what I'm connected to, and we could just the DRA could just support, let's say the user is coming with, I need 4 devices, then DRA could just support walking through that graph and giving out those 4 connected devices. Have you ever explored that idea before?
So you can use, sorry, I think if I understand correctly what you're saying, you can actually leverage the partitionable devices API to do something similar to what you just described. If you know that you always want something in, say, a group of 4 devices, you can create one or a set of different meta 4 devices that combine all 4 of them together. And then that's the thing that you request in your API. And then by the way that the partitional devices API works, once that has been allocated, the individual four that are backed by that kind of meta device aren't available for allocation anymore. So it's something that the DRA driver author would need to bake into the set of resources that he advertises in his resource slice. But that would allow the author to say, here's how I define this grouping, and I know that they'll always be asked for in groups of this size.
Yeah, the problem here is there can be different combinations, right? I can request 2, 3. So are you saying I have to publish that for all the different combinations?
If you wanted to go this route, otherwise, I think that's exactly what this match constraints API is designed to having you avoid having to do. You can say, you could have all the ones that you potentially want to group together. You could put a special attribute on them or something more complicated and then write an expression to define what that grouping is. I guess I'm trying to wrap my head around what you would picture as the way that you pull these 2, 4, whatever arbitrary number of devices together, if it wasn't something like pre-grouping them or using this cell expression to do that as user input.
So my thinking was I just define what I'm connected to, and I just claim give me 2 devices which are connected. Then it
Well,
these 2 devices are connected, and it gives out those devices without any additional fields.
the problem is you need to define what connected means. It sounds like you can do that with attributes and the match constraint or match attributes feature, which is a bespoke API for constraints where you basically say this attribute must have the same value across all devices. And if you have some way of identifying the connections and those are attributes, then this would be one way to do it without the cell expression. But that's just one subset of the constraint problem that we can solve with a dedicated API. And we do that. But on the other hand, we want also the flexibility to do so, to solve problems where we haven't defined a bespoke API with separate fields. And that's where the cell constraints become useful, even if they are more complicated to write.
Okay.
Ale, I see you're first with your hand up.
Yeah, I had so I had an idea regarding reducing the complexity or somehow boxing it. I wanted to share here and see if it was explored. So it looks like with the original cell expression, we are only limited to attributes, and with this cap, we want to open it up for other data that is present in the device struct outside of the attributes. So along with the match expression, can we?
No, that's not actually it. It's the same attributes and quantities as before. It's just across a set of devices instead of a single device. Yeah.
I see. So would it be like, I was wondering if we have an additional field that can somehow limit the additional devices you can reference to, for example, 4 or 8, that can put a finite number to the cost estimation?
The number is fixed. It's determined by the number of devices that you are requesting.
I see.
So it's the cell expectation. Yeah. And the cell constraint basically gets evaluated as soon as all the other the match constraints must be satisfied. The individual devices must satisfy the selectors. So once the allocator has a full solution, then it evaluates the cell constraint to figure out what as a last additional criteria whether that solution is suitable. And if the cell constraint returns false, it'll keep searching for something else.
I see. Yeah. Thanks.
Okay, Sasha, it looks like you're next.
Yeah, so I'm just trying to wrap my head around all of this. So imagine like I have like couple of dozens of devices, or each of them grouped by 4 using one of the attributes. What will be the syntax when I would say like I want to request 8 devices, but I want 2 full groups of 4? Will it be like one single request for 8 and one cell expression, or would it be from the same driver 2 requests like 2 times 4?
So for this use case, you can actually probably get away with using match attribute. So the driver can surface attributes like topology 8 ID, which basically just groups 8 devices together and assigns them a value of 0, for example. So what match attribute would do is it would compare the topology 8 ID and it would make sure that all devices that are selected have that same ID. So in this case, for your example, we could get away with using match attribute, and match expression, or this new cell expression wouldn't need to be used. Yeah.
But I have like 4 devices with one value of attribute and another 4 devices with another value of the same attribute.
I guess in your cell expression, you can specify which values that you're searching for. You can do like an OR expression as well.
Well, value might be dynamic, so I just want to have like 2 groups of devices which shares the same attribute. So
okay, I can look into that a bit more and get back to you
Thanks.
on that. Yeah.
Yeah, but
Thank you.
call out there that this is another issue with the KEP. We called it out in the KEP also. The usability of like people trying to express their intent. We need to over time simplify it or figure out how we make it super easy for folks to express easily what they're trying to ask.
All kind of cookbook with predefined recipes. Like if you want something like that, here's how you do it.
Yeah, a lot of examples. So a call out or request, if you have such use cases that you want to see us provide examples for, just start adding to the KEP review or to the issue. We'll try to come up with examples. Thank you.
Okay, Alex, it looks like you've got your hand up.
Yeah, hi. Yeah, thanks for sharing. I had one question about this. So it sounds like the costs are borne at the time that you've got some resource when you're seeking a resource. Has anyone looked at building an index across the resources so at creation time so that it's more efficient to match to a resource later? Because that's something that other systems in the world use to make that problem faster.
I think what the current design does, which is exactly like the match attribute, which allows you to build up an index and then have those optimizations. But if we plan on saying that we want it to be more expressive than building the index, raises the question, what exactly do you build the index on, right? Like how does one optimize for an unknown cell expression which the user could express? You could try and parse it, but like that raises another level of complexity.
Yeah, certainly you'd need some sort of schema for what you expect to query.
Yep.
Yeah, and this cell expression is meant to provide flexibility for users to select devices however they choose to. So building an index on an unknown could be difficult. Yeah.
Thanks.
Okay, Christian, do you want to take over from here?
Yeah, okay. So I think the best is if I show you basically what I've got here. So if I can share my screen. So do you see? And if you do see, is my font big enough, or do you need some? Do I need to zoom in? So is this readable?
Maybe one zoom would help.
Okay.
Thanks for asking.
Is it better?
I think that's good. Yeah.
Okay. So basically, I have a cluster here where I have a fairly recent Kubernetes setup and DRA enabled. And then I already have this DRA CPU driver. So this our hacked NRI policy with a DRA front end installed. But I can show you how easy it is to get it up and running, because I think the most interesting thing is that now, so if somebody is interested, this can be now taken into use really, really simply. Let me uninstall this. So now I have a empty cluster basically. So basically I have the image and the Helm chart published for this in my personal fork of our policy. So with a single command, you can, in principle, if everything goes fine, install it, get it up and running. Yeah. So basically what this does, so I don't know whether folks are familiar with what we have been doing with NRI. So me and my colleagues have been now for a few years experimenting with sort of alternative ways of plugging in resource management algorithms to a cluster. So instead of kubelet via the runtimes. And the vehicle that we use for that is NRI, the node resource interface. So this policy that I use here is not a kubelet component basically. So I have the topology manager, all the resource managers in the kubelet turned off, and then everything is plugged in via NRI. And NRI is basically taking the job of those normal, so the static policy basically. So how this works is that if a normal container creation comes in, it allocates the resources as it used to. But if something comes in via DRA, then it will allocate. So basically migrate any conflicts of those CPUs that via DRA has been allocated, updating the cluster state so that those CPUs become free, then answering back to DRA, and then once the container, and then uses CDI to inject. So just like the GPU drivers, uses then CDI basically to inject the CPU into the container, and then once the container creation comes in, then takes it from there. That's it. So I think, so in principle, very simple.
So, sorry, do you mind if I interrupt real quick?
Sure.
I just want to make sure I understand the flow. So you have a DRA driver that advertises CPUs as a set of
Yes.
resources in a resource slice.
Yes.
People request access to those using the normal resource claim or resource claim template mechanisms. The scheduler allocates a set of CPUs to the resource claim.
Yes.
Pod references that, and then when we do a prepare resources call, I guess something in your driver reserves those CPUs so that later when the
Yes.
container is getting started,
Yes.
the NRI plugin can pick those up
Yeah.
and actually make that CPU exclusive to
Yeah.
that pod.
Yes.
Is that
So
it?
basically
Okay,
we have,
got it.
so in a way, basically, so our old NRI driver in a way, or the NRI plugin, so it became schizophrenic. So it is both an NRI driver and the DRA driver, NRI plugin and the DRA driver. So it is the same component, which is, so basically how from the NRI plugin, how from this resource allocation plugin point of view, how the things works compared to a normal allocation is that at first, like you told, so first basically certain CPUs get reserved by a claim. And only after that the container creation comes in, which is referencing that claim. And then we see that, okay, this has been, so the claim has been reserving CPUs for this container. So let's assign it to this container and continue from there. So that's how it works.
Okay.
So
yeah, so the key is that you have both the DRA plugin and the NRI plugin running inside the same process that's managed as, I guess, a daemon set on Kubernetes.
Basically.
And then,
yes.
yeah, got it.
Yeah,
okay.
You
basically.
need to have a full state of a system. That's why you need to listen to NRI events from runtime. And then DRA is just for allocation.
For the allocation side of it, yeah. So DRA does the allocation, and then your NRI plugin does the actuation, I guess is the
yes.
Yeah.
Think about it. Yeah.
Yes. So basically what I did is that for the CPU abstraction, so our plugin has already a couple of, so quite a number of attributes it is collecting about CPUs, and I just did this naive implementation that, hey, I know about these CPU attributes, so let me just expose those directly via DRA to the rest of the system, and let's see how far we get and what kind of allocations we can do with using that and cell expressions. So this is basically how a CPU looks like in this abstraction. So basically, we expose most of the hardware details about the CPU. So like physical package, core, cluster, cache related information, die, what is the closest memory contrast, basically NUMA node information, frequency scaling, so minimum, maximum frequency, base frequency, and whether it's kernel isolated. Also, whether it's a P-core or an E-core or E-core. So that's the first thing that I tested, this P-core, E-core allocation. But because that was my laptop, because there I had both. But because this is a server here, I only have P-core, so that I cannot demonstrate. But as an alternative, I came up with a isolated allocation. So I have a couple of board specs here. So what I could do is I could show you this claim isolated, how it looks like. So this is how it looks like. So basically I have a resource claim template which says that I would like to have native CPU where the isolated attribute is true. And I just need one of those. And then I have a pod spec with a couple of those, with a couple of containers, which are all asking via this resource claim template for isolated CPUs. So if I hit the cluster with this, let's see what happens. So So 4 and 4 is running. So basically, I ended up with probably isolated CPUs allocated for that. So 4, 5, 6, 7, and CPU info. Sorry, command line. Yeah, so 4, 5, 6, and 7. So those are the isolated CPU sets. So I mean, so basically, with this simple abstraction, so some things you can already do and play around with. I also tested a couple of other things like full core allocation. That's also possible with this abstraction. So actually, quite a number of things. Then, so I don't know what else to tell about this. So the other interesting thing is that this really tries to. So if I first would basically take a normal workload, which is not using
Actually,
DRA to
Christian,
allocate CPU.
before
Yeah.
you do that, we've only got 5 more minutes, so maybe we should go ahead and open it up for questions so that people
Yeah, sure.
can ask them before we run out of time. Yeah. Francesco, I see you have your hand up.
Hey, thank you for raising this topic. Thank you for the demo. Very interesting. The question I have is which component owns the allocation of the CPU? Because we were discussing in the other proposal, namely, you ask, hey, I need 4 exclusive CPU. Who's doing the actual allocation on the node side, the plugin, the scheduler, someone else?
So if you come via DRA, it's the scheduler, because the scheduler will basically pick your CPU. So unless you are doing this kind of tricks that in a way one CPU device exposed via DRA is not always referencing the same CPU. So you can do these kind of things, but I didn't want to do that. Then you can do it that, hey, although the scheduler thinks that it's allocating a particular CPU, you are not allocating and assigning that one. But I think that's not the point. So that I didn't want to do. So now this works so that if you allocate via normal native resources, then the NRI plugin basically, which is the equivalent of in a way the corresponding kubelet components. So those are owning the allocation. But if the scheduler comes and basically allocates exclusive CPUs via DRA, then it has higher priority. So even if you have, so this now works so that even if it has assigned exclusively to a guaranteed QoS class pod and container, the CPUs, it has no choice but to migrate that off. So it tries to do, I mean, things a little bit, so relatively smartly. So what it will try to do is that it will basically free the CPUs previously allocated to the natively allocated, guaranteed exclusive container. And then it will try to allocate from within the same topology zone. So basically from the same NUMA node. So as close topologically as possible, that it is not really disrupting the workload, but there is no other choice. So in a way, DRA allocation is owned by the scheduler, other allocation is owned by the normal resource driver, which in this case is an NRI plugin, but in other case it could be the kubelet component.
Okay, thank you. I have
And I
follow-up
guess-
questions, but I will bring them offline. Okay, thanks.
Okay.
I see Praveen, you're next, but if I can just follow up on that question real quick. So with, I assume just like in the presentation we had in the last meeting, you still have to say like CPUs 4 in the normal pod request in addition to whatever DRA request you make in order
Yes.
to not confuse the scheduling. Yeah.
Yes, and
Okay.
I can show you what happens. So that is I can show you what happens if, so that is, so this is what happens if you don't do that. So basically we refuse to make an allocation because, so we make a check that basically the DRA, so in terms of DRA allocated CPU and the native CPU request, they are at least the same. So the
And
native
you're
one
able to
can be
make that
bigger.
check
Yeah.
in the NRI
Yes.
plugin because you have that
Yes.
information.
Yes,
Yeah.
and we can only make the check. So actually one thing I think that would be good to add to this is basically an admission webhook, which would automatically, so if the native
Guarantee that.
resource request, is, or no, not just guarantee, but if the native request is missing, then it would also inject it. So I think that would make this more usable, but I mean, I didn't want to fiddle around with that. So yeah, because
Makes sense.
otherwise the
Okay, yeah,
scheduler
sorry for
goes
interrupting you.
haywire.
So
Praveen,
it's actually
you're next.
where the help is needed. So we can handle allocation parts, but with webhooks, patches are welcome.
Yeah, so thanks, Christian. This was great. Like, I would love to play around with it. I had a question. So, the NRI plugin, like, is it also responsible for like once a container request like specific CPUs? Does it also go back and like remove those CPUs from like other containers that are already running?
Yes, it does.
Okay.
So basically, it handles a DRA allocation a little bit like it handles a normal exclusive CPU allocation. So for instance, when you allocate first a burstable container, then usually you assign it to all the CPU. So put it to some particular topology zone, and in that zone you assign it to all CPU cores. But then if you from that very same zone allocate exclusively a CPU, you need to migrate off other workloads from that. Just like the static policy is doing. So it's exactly the same. And once a DRA allocated container comes in, that is at the moment, that is by nature always an exclusive allocation. So you cannot do, so actually you can do shared allocation. So that's the funny thing, that you can do shared allocation with DRA already with this, but it's not that type of shared allocation like you do it with traditional native CPUs. But what you can do is that you do so you use a pod level resource claim for CPU. And then what happens is that you will allocate exclusively from the rest of the system point of view CPUs, and then you inject them to all containers in the pod. So they will be shared within the pod among the containers, but not with the rest of the system. But I think that, so that's a little bit tricky from this, so all this resource accounting calculation point of view, that how that should be accounted and how that should be checked. So I checked that it works, but I didn't play around too much with that. But that is also possible with the array.
Okay, sounds good. Thank you so much.
So
that good.
I think Ale, you had a question.
Okay,
We're almost
go
out of
ahead.
time, so I think this is going to be the last question, then we've got to wrap up the meeting. But go ahead.
Yeah, this is actually related to the last discussion we were having. So let's assume that we have a node with just 4 CPU cores, right? And there are daemon set pods that are running on that node with minimum amount of CPU, like 100M or 200M. Just for example, the NRI plugin. And if a request, DRA request comes in for workload requesting all 4 CPUs,
it will not come to that node. It will not. So I mean, the scheduler will never schedule it to that node. The scheduler will see that there is not enough free CPU capacity on that node, and either it will go to another node which has enough capacity, or it will stay in pending state until you until basically you remove some of the other containers, and then enough capacity is freed up so that the scheduler will be able to schedule it to the node. If this native versus DRA allocated, I mean, resource accounting is in sync and works correctly, then that's what should happen.
I see. So you can't basically steal cycles from this exclusively.
No.
Okay, got it.
So it's the overall problem of this double accounting. You need to make sure what the native is also specified.
So I think this is something that will become easier and better with these consumable resources once we have that in the array. So I think that then we might be able to work around this without having this webhook.
Is it even possible that, let's say for some use case, we want all the CPUs to be allocated to workload, but just see like platform cycles from that? Is it even possible to do it via this NRI plugin?
So you mean that, actually, I'm not sure what you mean. So what do you mean by stealing platform cycles?
So let's say I'm having a node with four CPU cores, right? And in order to manage that node, I need like a couple pods, platform pods, right? Like the NRI plugin or some daemon set pod monitor.
Okay, so basically you mean the control plane.
Control plane is running on that, not the Kubernetes control plane, but some daemon set pod that assists the workload is running on that node. But regardless of those pods, all the 4 CPU cores are exclusively to be given to workloads. And then when it is needed, the CPUs are, the platform pods are stealing 1 or 2 cycles from that exclusively allocated.
It's not. So even if you make all these what you call platform pods, even if you make them best effort, this is not possible. It's not possible with the static policy. The static policy will never agree to make such an allocation that the best effort container would be running with 0 CPU shares. So that it considers over allocation, and our policies work the same way. So you cannot exhaust fully So a best effort doesn't mean that it will be completely starved. That's not allowed.
I see. Okay, thanks. Sorry, we're running out of time. I'll probably take this discussion offline.
Yep, we're already 5 minutes over, so I think we'll go ahead and wrap this up, and we'll see everybody next time. Thanks everyone for joining.
Thank you. Bye.